Data bias. Data bias occurs when the data used to train AI isn't representative of the real-world population or problem it's supposed to address. AI systems learn from patterns in the data, and if this data has any sort of skew, whether due to overrepresentation or underrepresentation of certain groups or characteristics, the AI will learn those biases and produce biased outcomes. The root of data bias lies in the historical or societal inequalities reflected in datasets. Example: imagine you're training an AI to detect faces, but 90% of the training images are of people with light skin. When you use this AI to detect faces in the real world, it will struggle to recognize faces with darker skin tones accurately. You might notice this if you're using a facial recognition app, and it works perfectly for some friends but not others. If you're interested in learning how to work with unbiased data and avoid these kinds of pitfalls in AI, consider enrolling in a course on AI and machine learning in the links below. Algorithm bias. Algorithm bias happens when the built-in decision-making logic in AI leads to unequal treatment, even if the data itself is unbiased. Sometimes, designers unknowingly encode these biases into the system based on assumptions or design choices. In other cases, the algorithm may optimize for certain outcomes, but inadvertently prioritize characteristics that disproportionately affect specific groups. Example: think of a hiring algorithm designed to find the best candidates for a job. If the algorithm favors past job titles, it could unintentionally prefer candidates from certain backgrounds, even if they're equally qualified. Imagine applying for a job and wondering why you're never shortlisted, despite having similar experience to those who get called in. This could be a result of algorithm bias. Sampling bias. Sampling bias occurs when the subset of data used to train an AI model isn't diverse or representative of the overall population. This is problematic because the AI system will only learn from the cases included in the sample and may not generalize well to real-world situations. Sampling bias can lead to inaccurate predictions or discriminatory outcomes when applied to broader populations. Example: suppose an AI is trained to predict health outcomes, but primarily uses data from young, healthy individuals. If you're older or have specific health conditions, the AI's predictions may not be accurate for your situation because it hasn't been trained on people like you. Confirmation bias. Confirmation bias in AI happens when an algorithm reinforces existing patterns or beliefs, rather than learning objectively. This bias arises when the AI model favors outcomes that align with preconceived notions embedded in the data or system design. As a result, AI models can replicate or reinforce existing inequalities. Example: let's say an AI is trained to identify successful loan applicants, but the data includes mostly individuals with high incomes. The AI might then favor higher income as a key indicator, ignoring other factors like creditworthiness. If you're a small business owner with a solid track record but a modest income, the AI might wrongly classify you as a higher risk. Automation bias. Automation bias arises when people place too much trust in AI systems, assuming machines are inherently more accurate or objective than humans. This can lead to users deferring to AI-generated decisions, even when those decisions are flawed. Automation bias can worsen the effects of other biases, as it encourages uncritical trust in AI outputs. Example: imagine you're using an AI-powered navigation app and it directs you to a closed road. Even though you can see the road is blocked, you might still follow the AI's instructions, believing it knows better. This is automation bias in action, trusting the machine more than your own judgment. Historical bias. Historical bias occurs when AI models are trained on datasets that reflect societal inequalities or discriminatory trends from the past. The AI learns from these historical patterns and reproduces them in decision-making. This type of bias can perpetuate outdated or discriminatory practices, reinforcing the very issues AI is supposed to solve. Example: if an AI is trained on historical hiring data where men were predominantly hired for leadership roles, it may continue to recommend men for these positions, even though women are equally qualified today. Imagine applying for leadership roles and getting passed over just because the AI is reflecting outdated patterns. Group attribution bias. Group attribution bias happens when an AI system generalizes the characteristics or behavior of a small subset of a group to the entire group. This leads to stereotyping and inaccurate assumptions about individuals based on their demographic or group membership. Example: say an AI analyzes data showing that a small group of younger drivers tend to get more speeding tickets. If the AI generalizes this behavior to all young drivers, you could end up paying higher insurance premiums simply because you're young, even if you've never had a ticket. Interaction bias. Interaction bias happens when AI systems are influenced by the interactions they have with users. As people interact with AI, they introduce their own biases into the system through feedback or queries, causing the AI to reflect and reinforce those biases. Example: if many users ask an AI assistant biased or inappropriate questions, the AI may begin to respond in similarly biased ways. For instance, if users frequently make stereotypical statements about a particular group, the AI might inadvertently mirror those biases in future responses. Selection bias. Selection bias occurs when the data chosen for training AI is not properly representative of the broader population. This often happens when datasets are cherry-picked or filtered, leaving out critical variables that affect how the AI performs. As a result, the AI may make decisions based on a narrow view of the problem. Example: imagine a recommendation system that only uses data from certain regions or demographics. You might notice that the system frequently recommends products or services that don't match your preferences or cultural background because it was trained on a biased dataset. Survivorship bias. Survivorship bias occurs when an AI system only learns from successful cases or data points, ignoring failures or outliers. By focusing solely on survivors, the AI misses important information that could lead to more accurate decision-making. This bias can result in overly optimistic or distorted predictions. Example: if an AI is trained to predict which startups will succeed, but only looks at companies that already made it, it might overlook important factors that led to failures. If you're running a startup, the AI's advice might be less useful because it hasn't accounted for common pitfalls or challenges faced by other businesses. Measurement bias. Measurement bias arises when the variables used to measure outcomes aren't accurate, reliable, or consistent across different groups. This can lead to biased predictions or classifications, as the AI relies on flawed or incomplete metrics for its decisions. Example: suppose an AI is trained to assess employee productivity based on the number of emails sent per day. This measure might favor employees in roles that require constant communication, while undervaluing those in roles that involve deep focus or fewer emails. You could be penalized simply because your work doesn't fit the narrow definition of productivity measured by the AI. Framing bias. Framing bias occurs when the way a problem is defined influences the AI's decisions. The AI's decision-making process can be biased based on how the inputs or outcomes are framed, even if the data is neutral. Framing bias is often introduced during the problem definition stage and can lead the AI to focus on limited or skewed solutions. Example: if an AI system is asked to recommend products based on a user's shopping history, but only considers recent purchases, it might overlook long-term trends or preferences. Imagine you've bought holiday gifts recently, and suddenly the AI only recommends holiday-related items, even though your broader shopping interests are much more varied. This bias occurs because the problem was framed too narrowly. If you found this video helpful, don't forget to hit that subscribe button and turn on notifications so you never miss out on the latest technology and security tips